To inform the context of what we're going to discuss, I want to disclose one thing that you may or may not be aware of. My employer, Enbridge Gas, has recently gone into a merger process with Spectra Energy, which is the owner of Union Gas. As you're also probably aware, there are two major gas companies in Ontario, Enbridge Gas Distribution and Union Gas. Union Gas is wholly owned by Spectra Energy. So what this means is that sometime in the near future, the merger is going to be completed, probably in March, provided that it meets with all regulatory approvals. The interesting about the potential merger of the gas companies is that it sort of paints a picture of cooperation in the gas industry for the purpose of building out natural gas stations as well as renewable gas capturing assets as part of the utility that will help Ontario move forward to green the gas pipelines and therefore reduce our emissions and potentially as well clean up the air related as it relates to other emissions, not GHG, but other noxious emissions that come from Class 8 vehicles and other medium-duty vehicles. The other thing I wanted to do is just share this video with you. It talks about, it has two examples, and it's available on YouTube, but it'll help inform the context of what I'm about to present.
Especially here in southern Ontario, that natural gas could be part of a much broader, holistic approach to transportation. Having natural gas as a fuel rather than diesel for heavy-duty trucks is highly cost-effective and reduces greenhouse gas emissions right off the bat by 30% or more. The first adopters of natural gas have been private trucking companies.
When we started, we were the first ones in Canada. We currently operate 131 trucks on liquefied natural gas. People would be very surprised to hear that the food that they have on the table is actually brought to them by natural gas powered trucks. The big thing about natural gas, it's a cleaner fuel, it's a much safer fuel, and it's also a cheaper fuel.
As there's a price on carbon, you'll see more and more of the owners of the truck fleets switching to natural gas, or the cities in their bus fleets, or garbage collection.
I think natural gas is an ally for environment changes. It's probably the only alternative fuel that's readily available right now for transportation, and we can have a much cleaner environment by using natural gas.
Hamilton has been continuously operating natural gas buses for the last 30 years. From the driver's seat in virtually any bus, they all look the same from the dash out through the window. What they do notice is that the natural gas bus is more quiet. It's our responsibility to make sure that we do the best we can to keep the climate clean, and the people riding the bus should not notice the difference. I just want them to get on the bus on time and go to work and get to school, whatever they need to do. I'm proud being an employee at the Hamilton Street Railway because we spend the time required to make positive changes and to stick with those positive changes as the years go by.
We see more and more customers coming to us and asking for their transportation to be done with the liquefied natural gas trucks because once again they want to reduce their carbon footprint, and group of air is part of that equation.
We have found nothing but positive results in talking to long-term, old-type diesel guys who said, you know, this is just like driving a diesel now. I have the reliability that I used to have, I have the power I used to have, but I have cleaner air than I used to have.
So with that said, you don't need my lecture, you can just go to cleanaffordable.ca. That's right. So as you've probably gathered, what we're going to be talking about today is the prospect of using natural gas as a transportation fuel, and how the sort of so-called circular economy can be enabled by the capture of waste sources of solid energy in the form of waste, and that can be cleaned up, injected, and put into our pipeline, and eventually wheeled to users of natural gas for on-road trucking and busing. So I'm not sure if any of you have seen this picture before. This graphic was produced by our government to sort of share their vision of what 2050 will look like from an energy perspective in Ontario. And it's quite a laudable vision. You can see that most of our energy in this picture comes from renewable sources. Each of those black sticks that you see speaks to a particular action item that can be found in the Climate Change Action Plan. And if you were to Google Ontario Climate Change Action Plan, it would bring you to an 80-page document or PDF on the Ministry of the Environment website, where all this is explained in greater detail. I don't know how that happened, but I guess I shrunk the circle. Anyway, this area that I'm circling here, which encompasses these vehicles, sort of give you a sense that electrification is our destiny. And we sort of believe that too, that a lot of light-duty vehicles, electrification is clearly the future. It's probably where most light-duty vehicles are going. There might be some opportunities for light-duty vehicles to be powered by renewable natural gas or other biofuels, but for most of us in Ontario, where the grid is our electric grid rather, is very green, it's more likely than not that electrification is in our near future. A government or two may come in and slow that process down or speed it up, but that is where we are going. Don't kid yourself. The other curious thing about this picture is that there's no picture at the bottom of a heavy-duty Class 8 truck, which is interesting because when I travel the highways, whether there's the 401 or the 410 or the QEW, all I see are heavy-duty trucks. So this picture isn't telling the whole truth, because it's not honing in on something which is very important to all of us, which is how we get our material, how we get our food, how we get some of our energy in liquid form. But at the very least, it does acknowledge that heavy-duty vehicles, as one of Ontario's action items, will be powered by potentially biogas and other related fuels. So I thought before we go too far, I should give you the required Enbridge safety briefing. As part of our procedures at Enbridge, we have to start every presentation with a safety briefing. So let's talk about natural gas. It's colorless, it's odorless, it's lighter than air. Interestingly enough, it's not poisonous. It is an asphyxiant. When you look at old movies and you see people sticking their head in the oven, we often think that they're being poisoned. They're not. In fact, back up. They could be being poisoned if their oven was powered by coke gas or coal gas. Consumers Gas, which is the antecedent body of Enbridge Gas, did produce coke gas, and the streets of Toronto were lit with that type of fuel. But the gas that we get from the ground, natural gas, will not. It's not poisonous. It is smelly, however. The other thing is, natural gas is not. It's only flammable in a very narrow range, 5% to 15% concentration in air. So the stuff that you smell in the gas is mercaptan. That's actually added as a safety feature, and similar things are added to liquids as well. To give us a pre-warning that there's been an emission or a leak of sorts. So the things you want to look for or note are smell, Look for things that you can see, blowing dirt, bubbling water, dead vegetation. If a pipeline is underground and you see and it is leaking, there will be a trail of dead vegetation, and that comes from the fact that the gas is asphyxiating the vegetation. So part of the reason that mercaptan is such an effective safety measure for gas is that you can start to smell it at 1/16 of the value or concentration before it actually becomes flammable. So if you were to walk past a pressure regulator or a meter and you smell the teeny bit of natural gas, it's probably not, unless you heard a hissing sound or something visible that indicated that there was something wrong, what you're probably smelling is just a little bit of a burp in the system. These systems, actually, that's in fact what they call it. The technical word is burp. But anyway, that there is just to give you fair warning that the gas is there. So of course, if you detect gas, call us, call 911, or call Enbridge Gas at our main line, and we'll get someone out to look at your situation. So compressed natural gas. They talked about LNG in the video. Compressed natural gas. I could probably skip through this because I know that you guys are well aware of what compressed natural gas is. It's just like regular gas. The vast majority of the market that uses natural gas as a fuel uses CNG. Liquefied natural gas. So in Ontario, there's one site that actually produces liquefied natural gas, and it's in Union Gas territory. LNG is actually not produced as a transportation fuel. It's actually produced as a means of storing energy. So the applications that are being pondered for liquefied natural gas in Ontario tend not to be transportation opportunities. They tend to be more related to energy storage or energy mobility. So creating a so-called rubber road for remote communities, as well as mining operations, things like that. So if you really wanted to clean up, the operations at Inco or Extrata or in Northern Ontario, you might consider, wheeling natural gas to there. And LNG would be an efficient way of doing it because of its it has a density which is at least in the same order of magnitude as liquid fuels, in the sense that it's 60% of the density of gasoline or diesel, but it's not 1/614th. So, having said that, compressed natural gas can also be wheeled. It's technically feasible. There are TSSA regulatory questions around the movement of natural gas, which has created an area which, maybe John, I could point to you. Propane has won the day in construction applications. There aren't many construction applications that use natural gas, although that is something that could certainly be possible if we're successful in pleading our case in the future. So as I said, limited availability. The video that you saw earlier with Group Robert alluding to the use of LNG, that gas is actually trucked in from Gaz Metro in Montreal, and Robert made a business decision, and apparently it's worked out okay. They may in fact choose a different fuel for the next iteration of trucks. So interestingly, LNG is not odorized. There is no mercaptan in LNG. It is simply compressed and turned into a liquid and stored in the vehicle. So natural gas as a fuel for vehicles actually has a fairly lengthy history. In addition to this picture, you can see the cylinders on the roof. I'm not exactly sure what year that would be. I would expect it would be in the 1940s. I have another one here. That vehicle looks like it's circa 1920. And John, have you ever worked on this kind of equipment? No? I don't think that says fuel maker brand on there. But just the same, I mean, there is a long history of natural gas. And I apologize for the joke. I was just...
Well, that's why no, it's good. Provide all the anecdotes you like.
But anyway, it does have a long history. Henry Ford, when he came up with the Model T, was fuel agnostic, and he made his vehicles such that they could run on oil, on whatever petroleum they had of the day, as alcohols, natural gas. So there's a lot of stuff that you can find in the public spaces about sort of controversies around why we went the direction we went with Standard Oil and Rockefeller and stuff like that. I'm not going to get into that, but suffice to say, natural gas has been around as a transportation fuel for quite a while. This particular graphic, it's pretty busy, but it gets into the sort of arc of where natural gas has been over the past 20-odd years in Ontario. You'll notice that at its peak we had 39 public stations. The original business model for CNG for compressed natural gas in Ontario was, if we build it, they will come. So we built a lot of stations, we converted a lot of vehicles, and they started to come. We had some successes. The traditional combustion engine technology got better. One of the problems that we had in our more particular market was that all our vehicles were conversions. Conversions were the only thing that were available. You couldn't get factory ready or factory approved biofuel vehicles. You couldn't, and you also had the introduction of fuel injection systems and things like that. And I'm told that when that technological change occurred, the actual engines became problematic, and there were maintenance issues with the first and second generations of CNG vehicles, or NGVs rather. So for a long time, as you follow this temporally, natural gas was in fact cheaper than traditional petroleum. What happened is that at a certain point, natural gas became quite expensive. There seemed to be a very limited supply, and the price advantage of natural gas as a fuel disappeared. And when that disappeared, it was sort of the final nail in the coffin of NGV, of the NGV position for light-duty vehicles. Those who were dabbling in the market, like Honda, got out of the market, and not only did they get out of the market, they also got out of the market of producing fueling systems, because Honda and at one point Magna owned the major company that made the home fueling systems, which were quite ubiquitous at the time in the NGV industry. So in addition to these 39 public stations, you had the option of fueling from your home. So what's happened since is that the discovery of shale gas in the later on in the 2000s, later on in the aughts, changed that metric. So no longer was natural gas tied to the price of a barrel of oil. They became decoupled. When that decoupling occurred, natural gas fell, and it's continued to stay there, in the bottom. It's been there at the bottom of the price range. Right now, I think natural gas is trading at around $3 a gigajoule. It goes up and down. You could double the price of natural gas from a commodity perspective. It would still be very, very cheap. And because we have this, supply, some people say 100-year supply. Some people say a 200-year supply of natural gas. It looks like it's going to be inexpensive for a while to come. So we have one problem sort of solved. So one of the conditions one of the enabling conditions to recreate an NGV market is having a price advantage and having a significant price advantage. If you consider that you know, a liter of diesel is about $1. If you were to buy rack price in bulk, it's around 85 cents. The commodity cost for 1 cubic meter of natural gas is, if you have a rate 6 account, which is a small user, non-interruptible account, your landed cost for that cube of natural gas in your home is about 25 cents. What's interesting is that 1 cubic meter of natural gas is approximately equal to 1 DLE, or diesel liter equivalent, and it's also approximately equal in terms of energy content to 1 GLE, or 1 gasoline liter equivalent. I think it's 0.89 liters of diesel equals 1 cubic meter of gas. So if you divide by 1, you end up with, if you were to divide 25 cents per cubic meter divided by 0.89, you'd come up with around 27 cents or something like that. That will be your commodity cost for natural gas if you're a small user. If you're a large user, if you're using and you have a fixed consumption of natural gas, that cost of fuel can drop. It can drop down into the 20s. So with you know, a 50 or 60 cent spark gap between diesel or gasoline and natural gas, the price advantage isn't just there. It's a robust, secure price advantage that you can plan your business around. So the other thing informing why we're here today is cap and trade. It's widely acknowledged that natural gas has, as a fuel, without even talking about renewable sources of gas, has an emissions advantage. And furthermore, it provides a path to a renewable future, which we will get into in a little bit. But under cap and trade, the Ontario Climate Change Action Plan, gas utilities as well as fuel distributors are compelled to buy allowances, emission allowances for you folks. So if you're what's considered a large emitter, you can go and you participate in an auction process to purchase the right to emit, like which are called emission allowances. But for most of us, we're just going up to the pump. We're heating our homes with natural gas, or we're putting natural gas into our buses and trucks and cars. For us, that the cap and trade, it's a tax. Let's call it what it is. It's a tax. It's going to be about a 5-cent fuel tax added onto each liter. Now, natural gas is not exempt. For natural gas, it's going to result in an increase of around somewhere in the order of 3 to 3.5 cents per cubic meter. It won't show up on your gas bill, but it is there. Just as it is for every liter of natural gas, it's going to be somewhere in the order between 4.3 and 5 cents per liter. Anyway, the proceeds, all this money is going to collected by the various fuelers, by the gas companies, and by propane dealers and gas stations and what have you. We effectively are becoming the collection agency for the government for these revenues. These revenues are going to be earmarked for abatement measures. There's a whole list of different abatement measures and action items which you will recall from the first slide. They were listed there. There's everything from bike lanes to home heat pumps to free electric recharging, things like that. The key action item that we're talking about are the ones related to these two items. $270 million is being earmarked for natural gas fueling and infrastructure and vehicle conversions. That word conversion is a bit of a misnomer, and I probably should have changed it. When they say conversions, what they really mean is when a vehicle fleet goes through its natural life cycle renewal processes, where a fleet manager purchases or leases new vehicles, he's in a position, or she's in a position, to convert their fleet truck by truck to natural gas or whatever fuel they elect to use. So natural gas fueling infrastructure is in the Climate Change Action Plan is called low carbon fueling infrastructure. It was probably more palatable to put it that way. But essentially, of this $270 million that we expect to get from gas and natural gas and diesel, from that kitty, of that $270 million, in approximately 2-to-1 ratio, $150 million will be allocated for the vehicle upcharge or for improving the vehicles. Our understanding is now that the Ontario Trucking Association and potentially OPTA, which is the Ontario Public Transit Association, are going to be the folks that are sort of guiding their particular constituencies on how to obtain those funds in terms of incentives. And the incentives could be something like $30,000 to $60,000 per vehicle, which would go a long way to covering the incremental cost of having a natural gas engine. So there's one company in particular called Cummins Westport who makes a product which is sort of taking over our industry. Most of actually all of the Class 8 tractors and all of the natural gas buses that you see on the road in Canada will have a Cummins Westport ISL or ISG engine in it. What's interesting is that with the new CARB standards coming out, they are the first company and only one so far that have come up with an engine that is deemed near zero, where the reductions of NOx and carbon dioxide and other pollutants are dramatically lowered from even the existing emissions levels. We're talking about being able to use these fuels in almost like in indoor applications, similar to like a Zamboni. They're that clean. So look for, if you're interested in this topic, I suggest that you Google the term near zero engine or Cummins Westport near zero engine. It'll give you a flavor from a technological perspective of one of the other sort of enabling technologies that is going to allow this market to take off again. So the first one was the low cost of gas. The other is the prospect of near zero emission engine technologies. So they don't require all of the filtration or after exhaust treatment to clean up the exhaust. It's built into the engine, and they're remarkable technologies. So, having spoken about the incremental cost and the upgrade to the engines, that leaves about roughly $100 to $120 million for building up fueling infrastructure. You saw we had at our peak 39 public fueling stations. There are now 6 left in Ontario, but it doesn't really matter. Those 6 public fueling stations that we have for natural gas wouldn't be able to efficiently fuel any of these large heavy-duty vehicles that we're talking about. They wouldn't be able to fuel large straight trucks. They wouldn't be able to fuel tractor trailers. They would not be able to fuel buses efficiently. They would be there for like a month of Sundays trying to get the job done, particularly for large fleets that need things like 3 or 4 minute fills. If you talk to LA Transit, if you talk to Calgary Transit, if you talk to the TTC, the standard is 3 to 5 minutes of fueling time. That's what they need. And so the way that you accomplish that is just by getting huge compressors, having drives to soften the starting sequence of those compressors, and just going bang, just shoving that gas into the tanks. So of that $100 to $120 million that I referred to, we figure at Enbridge Gas, between us and our colleagues at Union, that that will provide enough funding to build out 20 to 25 stations along the 400 series highways. So you may or may not be aware, but Enercan, as their own attempt to be the tip of this spear, have recently funded 6 stations across Canada, 4 of which are going to show up in Ontario. 3 of them are going to be along the 401 between Windsor and here. One will be in Windsor, one might be in London, and the other might be in Woodstock. We're not exactly sure. And another station will be, which will be a public station meant for big trucks, will be in the Niagara area. So the 4 stations that we have will support the network that was started with the primary node that we have for a natural gas fueling network, which is on the southwest side of Pearson Airport. There's a station called Gain Terra, and right now there are 50 odd trucks as well as 180 garbage trucks fueling out of that particular facility. So it looks like we have the first station in place, which has proved the concept. That's the one southwest of the airport. We're going to have an additional 4 stations in the next year to further support the efforts of folks like Chrysler, Canadian American Transport, etc. And then 2018 and beyond, we're talking about building out this next 25 to 30 stations across Ontario. I have to think that a lot of those are going to be along the 401 and in and around the airport. So our major logistic zones are, this area out to Brantford, as well as the area from Mississauga out to Vaughan, north and south along the various corridors that go up there. We're going to need to build stations along there. How that's going to happen, we're not sure yet. There's going to be a process of stakeholdering and engagement that takes place. Public actors like Partners in Project Green are going to have an opportunity to give their comments on behalf of their constituency, which would be businesses in and around the airport. We're going to be talking to regional governments, folks like Peel Region, Durham Region. Union Gas will probably be talking to your local government here, because this is a community effort. The effects of and the outcomes are going to have direct impacts on the community. So the stakeholding process is probably going to be it's going to be fairly extensive, and it's going to involve some of the major carriers, both private and corporate ones like Schneider National or Challenger. They're all going to be involved in these discussions. So the other point not to be dismissed is $120 million for renewable natural gas over the next 5 years. Does anybody here know what renewable natural gas is?
Renewable natural gas is the anaerobic digestion, but it also can come from hydrogen injection to power gas.
Yes, that's correct. That's correct. Can you, so renewable natural gas, what most of the time what I mean when I say renewable natural gas, I mean gas that's come from an anaerobic digester or a landfill or what have you, but it's been cleaned up and purified to a pipeline standard such that it's for our intents and purposes, indistinguishable from fossil gas or from paleo gas, whatever you want to call it. Right now, most of the biogas in Ontario, with most municipalities who are using it who are producing it by virtue of their processes for treating liquid waste or for landfill or what have you, it's simply being flared, the intent here is to first spend $20 million to prove some concepts, and then use the other $120 million to help the utilities work with different folks, and it's not always going to be the public sector. I mean, although the city of Toronto produces quite a bit of garbage, Durham Region and Peel Region produce quite a bit of garbage. I'm sure KW produces quite a bit of garbage. The fact is that there are also a lot of industrials that can play in this space as well. Folks in the food business, in the beer making business, folks in the grocery sector. All of them have a role to play. A typical grocery store, for example, gets rid of, and we're talking about a 50,000 square foot grocery store, disposes of 3 tons of green waste per week, and it's costing them $300 a ton. So basically $1,000 a week is their cost for disposing of of what to somebody who owns an anaerobic digester is liquid gold or solid gold. It's liquid. I went to liquid because it becomes a slurry first. But anyway, these things are happening. Discussions are happening right now. I understand that there are folks at Waterloo with an interest in these technologies. I'm sure we'll be in more dialogue as the months and years unfold. Just to come back to what we're trying to address with natural gas, we're not really talking about gasoline. We're We're not really talking about off-road. We're talking about this, diesel. Diesel is where where natural gas can have the largest, quickest impact. And I have Class 8 trucks circled because it's the single, for two reasons. On a per vehicle basis, it has the highest highest fuel consumption, but it's also the most ubiquitous. We'll move forward. This is information that's available from CUDA. If you add it up, if you take all the buses in Ontario and their total fuel consumption, including biodiesel, by the way, it adds up to around 300 million liters of diesel per year. It's not an insignificant number. It's measurable. But look at this. I got this from StatsCan. If we look at our net sales of diesel, we're around 18 billion liters. 18 billion liters of diesel consumed per year. So the ratio of diesel consumption for transit buses versus all diesel is 60-1. The only reason that I bring this up is because in the public space, in our imaginations, there seems to be, in my experience, a disproportionately large amount of effort spent on greening these 300 million liters of diesel that are burned by buses. And while that's all well and good, to me, this is the real prize. This represents actually 1.6%. So if you're spending 30% or 40% of your time on 1.6% of the addressable market, it's a misallocation of resources. So if I had a policy maker in front of me, and he was trying to explain to me or why so much of our efforts at greening are focused on transit, I would say, is that really the best use? Should we not be looking at Class 8 trucking? Should the number that we have for vehicle conversions be 270 million, or should it be higher? Let's think about how we're using our resources, because if we want to have a big effect, just to spend 30, 40%, 50% of your time on a small fraction of the market, it just doesn't seem to work for me. So I included this slide because it's a really good summary of the reasons for adopting CNG versus diesel. Almost 100% reduction in sulfur dioxide, nitrogen dioxide, NO2, between 75 to 95%, VOCs 90%, CO2. That's almost like an afterthought, right? Let's think about the air that we breathe. Let's think about the little ocean of air that we have to live in on a day-to-day basis, where our kids are growing up, where our parents are living, the air basins that we live in. And I'm not saying that GHGs are not important, not at all. That's not my point. My point is that in the vicinity of LAX, of Los Angeles International Airport, they converted a lot of their vehicles, taxi cabs, to natural gas. All the shuttles work on natural gas. They had a measurable improvement in the LAX area by getting rid of all this stuff. And what did they find? Over a 20-year period, children's lung capacity increased substantially, immeasurably, on the order of 10-15%. That's a big deal. It's a lot of kids that are living happier, healthier, longer, smarter lives. They're kids that are less likely to commit crimes. They're kids that are going to be more employable. They're going to, So there's a whole bunch of outcomes. When you look at it from a macroscopic perspective on the health effects and stuff like that, I mean, of course GHG is important, but carbon dioxide is not a poison, right? It's problematic. It's something we need to address. But if you want to take Hogtown, Smogtown, and make it a clean town, we can get there a lot faster with economic benefits and still have an improvement in our carbon dioxide output by adopting CNG as a fuel. So just something to inform the context of what we're talking about, because some folks seem to think that you know, by advocating CNG for buses or trucks and things like that, by not embracing electrification, that we're not embracing change. That's not true at all. At Enbridge Gas, we are one of the largest owners of renewable assets. We recognize at the gas company that our future is a low carbon one, and that the stuff that we're going to have in our pipelines is going to be low carbon fuels, whether it's a renewable natural gas or renewably produced synth gas, things like that. That's our future, and we put our money where our mouth is. Since 2012, we have about at least 1 gigawatts of renewables in our custody, that we own. Roughly 2/3 of that is wind. The rest is photovoltaic. But in addition to that, you should know that Enbridge Gas, we've broken ground on a hydrogen facility. We expect the construction of this hydrogen production facility that we have in Markham to be completed sometime in the new year. But that's part of our game plan, is to take renewable energy, produce hydrogen with it, and then do useful things with it. So the interesting thing about CNG and RNG is that they provide a path to greening Ontario's gas grid. So this is where I bring up my propaganda. Enbridge Gas, as you know, we've had a long history with natural gas. We've built over 80 stations, but we've actually operated over 20 CNG fueling stations over our recent history. And our own fleet of 800 vehicles, over 600 of our 800 vehicles are natural gas. So if people need help converting their fleet to natural gas, if Waterloo wanted to convert some of their fleet to natural gas, we could certainly help you with that discussion. We'd probably involve Union Gas. But if it's something that you guys ever want to consider, let us know. We're happy to go through a fleet analysis. We have programs that for offering financial assistance through a rental infrastructure program. Where natural gas right now makes the most sense for private fleets are in return-to-base applications. So, do I mean taxi cabs? Sort of. I certainly wouldn't to tell a fleet owner or a fleet owner no. But where we think the opportunities lie are in return-to-base fleets like this, great wine and spirit truck, this straight truck, day cabs, and highway sleepers as well. We're only a couple years away. If we start today, as we are starting today, and we could just convert a small percentage of our fleet, within a decade, we could accomplish that goal. We could accomplish that goal of drastically reducing the amount of diesel in our system. So a couple other examples of natural gas being used in Ontario. HSR, you saw that example. This morning's conversation between yourself, Eric, and you, John, it talked about time fill. This is what time fill posts look like. There are occasions where having a lot of accessible power to rapidly fuel a vehicle, it comes with high infrastructure costs. It therefore becomes, therefore in certain applications where you have a fleet with a significant amount of downtime, you can smooth out the filling of those vehicles and reduce your capital costs by going with what's called a time fill some of the time. And that's what that picture on the left is demonstrating. Here's some other vehicles to take a look at. On the right-hand side, you see on a typical bus, that's where how fuel is stored on buses in Hamilton, for example. If you were to go there, you wouldn't actually see those tanks on the roof. They have a shroud covering them. but that's where the fuel is stored. It's not stored underneath the vehicle. And this is what a typical station looks like. This is where Enbridge starts. This is the gas supply. When you pull the gas out of the pipes, oftentimes you need to remove moisture, and so there's a treatment process with a gas dryer or dryers, an array of dryers to remove that moisture. Removing that moisture from the gas, what it means is that when you go to combust that gas, there'll be fewer problems because you're getting a cleaner, more efficient. You don't have to deal with the latent energy of the water in the gas if you've removed it, and so it's nicer to your engine. There's a compressor. A compressor is it's not really that much different from an air compressor. It's just compressing a different type of gas. It's compressing natural gas instead of air. What's neat about these compressors is that with a lot of the compressor manufacturers nowadays, you can have them built in a modular way, such that, let's say that you had a 150 horsepower compressor here, which could, let's say, fill, I don't know, 20 diesel trucks. Well, if you ended up growing your fleet and needing more trucks, you could almost add these compressors modularly and have the same effect in terms of fueling. This is a priority panel. The question came up this morning. This is what controls the cycling of the compressor. And this is the storage or buffer system, which smooths out the operation. You can think of it as like a capacitor in an electric circuit. It sort of smooths out the operation of a compressor. And this is, of course, the dispensing system. I wish I knew somebody who was in this business. So this is the long-term view, or longer-term view. Closer to 2050, where we would like to play is cleanup and injection of fuels produced in biogas plants. So Peel Region, Toronto, Durham are all building these sorts of facilities. We're going to have more discussions with other municipalities as time goes on. But essentially, this is what we'd like to do. And this is what we are actually being compelled to do, and that's what the $120 million for RNG is sort of budgeted for. It's being budgeted for this sort of stuff. One of the interesting things that's not shown here is woody mass as an opportunity for creating RNG. I understand that there are some folks in the low carbon transportation network who are working on woody mass as a source of biogas. But you have corn stalks here. You also have the grocery waste that I alluded to, as well as street side organics. And finally, here we are at the end. What's interesting about this slide is it sort of shows an example, a secular example of what we're talking about. You have the street side organics picked up by the garbage truck. The waste ends up at a biogas plant. Methane's produced, and that methane goes back in to power the very garbage truck that brought the fuel there. Sorry, that brought the garbage from the house to the digester. So just an interesting point, substituting only 6% of the natural gas in our system it represents 14 terawatt hours. On a peak day, the electric power plant in Ontario, in its entirety, including all sources, thermal, nuclear, hydroelectric, produces somewhere on the order of 25 terawatt hours. At any given time, on a peak day, the gas pipelines can produce 81 terawatt hours. So by a factor of more than 3 to 1, as a source of energy, Ontario uses a heck of a lot of gaseous energy. So the notion that we can completely electrify in a short period of time is a real technical challenge. We submit that the gas grid, having been invested in by the people of Ontario for 160 years, underground as a safe, fairly safe storage means of storing energy, probably affords Ontario the best opportunity for storing renewables. So if you want the green future that we're talking about, this is probably the right path, or it's probably one of the right vectors to think about as a tool in greening our grids, because they're connected. The gas grid and the electric grid are connected. They're completely fungible from one source to another, as we're proving. But this 14 terawatt hours is significant because just 6% of our gas is what we think that we could probably displace with just the street side organics that are available along the curbs of Ontario's houses, as well as other green waste that's currently entering most municipal supplies. 6% is 4 Pickering reactors. It's the equivalent amount of power. So if we need to go from 25 to 81 in terms of our heat usage, and let's assume for a second that we insulated all the buildings and we made them all more energy efficient, that we could cut their energy use intensity by half. So take that 81 that I'm talking about and make it 40. There's still a gap. There's still a gap of 15 terawatt hours. So which would mean that you'd need 4 to 9 additional Pickering reactors. And I'm just making this up, so just forgive me. But where are we going to put them? There are only so many rivers and lakes that will accommodate them. Most people don't want them in their backyard. Therefore, I think that we talk our way through this, we're going to see that bio sources of fuel, liquids and gaseous fuels are probably going to be a significant part of our future for the next from now until 2050. That's it, guys. Thank you. Any questions?
Any questions?
I think it was slide 23 that you showed.
Slide
23? Okay.
Yeah, you showed that there's a compressor and then another section and then the final end users. So did you calculate how much CO2 or any kind of pollution will be produced in that middle part?
Well, this from here to here is all electrically driven. This is actually a gas station. This is actually a gas station, right here. This is where the pipe starts. Are you talking about well to wheels?
No, in this section. So here.
From here to here?
Yeah, for gasoline, for example, we don't need this section, right? So we bring the production from refinery and use.
Yeah, so it's about it's a good point. I'm working on one right now, which is 2,000 horsepower, and the electric. I would probably need 1 megawatt of power. It depends on your source of electricity. It's as green as your source of electricity is green. So if I were to burn natural gas to power a generator to run this, it wouldn't be. There would be emissions associated with this that I would have to account for. And you're absolutely right. But in Ontario, it's a very green grid. It's a very green grid.
But you can use, for example,
especially
suggestion. For example, you can use renewable energy in this section too, like solar panels or any kind of wind turbine for here, to have green compressor and reduce that pollution too, right? Like
yeah, I know, but sure. I suppose it's technically doable, but this is reliant. This is all the assumptions here are that this is plugged into a grid. So what you're saying, I think, maybe is that you could every one of these stations could become a fit opportunity, a feed-in tariff opportunity, which is true. And I mean that's true of any electrical appliance, but I wouldn't dispute that.
More questions? I guess that's it. So, Tariq, on behalf of University of Waterloo, we would like to thank you for your time and thank you so much for sharing some very valuable information with us. Thank you so much.
Okay, you're welcome. Thanks.